Okay, Abby, I changed my mind when I looked at these problems. I'm going to go ahead and work through them with you. This problem here we did in class on Friday. This was problem, I think, number 15 on 4.5. But I'm going to go ahead and do it again because the problem that you had here, I went back and looked at your work, both at your work and at where you tried to do the correction. And it is the difficulty that has to do with negative signs. I'm going to take it exactly to what you had done at first. You were moving your a's over to the left-hand side of the equation, and you had 4 minus 9a minus 3a plus 10 is equal to a negative 10. And you're exactly correct at that point, and then you thought, okay, I'm going to collect like terms now. So you have 4 plus 10, and actually that's a second problem that showed up, I think. Let me see. No, it didn't. Okay. 4 plus 10 obviously is 14. But then you said that negative 9a minus 3a gave you a negative 6a. And I think that as I highlight, and you did that both times, that was the error that you repeated when you were trying to do your correction. Negative a minus 3a, and that may be what I was talking about earlier. Remember that the sign always is involved, because if you did just 9a minus 3a, well, 9a minus 3a, maybe you think it's a negative 6a. I'm not exactly sure that I can figure out exactly what you've got going on here. Um, 28. But if you have a negative 9 minus 3, you can think of that two different ways. You already owe your mom $9. You borrow $3 more from her. How much money do you owe her now? You owe her $12. You can think of this negative sign as being owing. You can look at this, think of it now on a number line. Okay, we're 0 there. Here we are at negative 9. Remember, to the left on the number line is negative. To the right on the number line is positive. You're going to start at negative 9 on the number line, and you're going to hop 3 more units to the left. Negative 10, negative 11, and negative 12. So if you visualize that, you know what's actually going on. You're subtracting. Anytime you subtract something, you can say that you're subtracting 3. You're moving to the left on the number line. Another way that you can think of this, as they teach in begin teaching in pre-algebra, is that subtraction here is the same as adding the opposite. So you have a negative 9 minus 3. Instead of subtracting 3, we're going to add, instead of subtracting a positive 3, we're adding the opposite. When you add integers that have the same signs, you keep their sign. You take their absolute value. 9 plus 3 is 12. But it's a negative 12 because both of them have the negative sign in front of them. But that's what you had going on, and this is another example of what I was seeing on your test where you're having some difficulty with those negatives. So once we correct this, and we realize that negative 9a minus 3a is a negative 12a, then your problem goes away. Negative 12a, and you have negative 12a is equal to negative 24. You divide both sides of that equation by a negative 2. You divide both sides of that equation by negative 12, and you end up with your positive 2 that your book says, and you were trying to match your answer to the book and you couldn't do that. So that's what you had going on there. It's all issues wrapped up around negative signs. So this other one, you said you were having issues solving equations that contain multiple variables. You are not the only one that has issues with that. It's a strange seeming animal to work with. You're about the only one that tells me that you have issues with it, though. They're variables instead of numbers, but the properties are the same, where you use inverse operations, where you can add or subtract, multiply or divide on both sides of the equation to keep things in balance. It's the same properties here. What were we going to do on this one? They wanted to solve for x. So when you are solving an equation for a variable, what are we doing? We're isolating whatever we're solving for. So that means we have to get, if that variable shows up in more than one place or more than one side of the equation like it does here, we have to get all of them on the same side. So we're going to either move the mx over here or the 2mx to the left. And then once we've done that, we have to isolate our variable so we have just one x. Because we don't care about mx, we don't care about 2mx, we only want to figure out what x is. Now I'm going to go ahead and I'm going to solve where we have the x on the right hand side of the equation, because I know that you can track with this. I'm going to put the x on the right hand side of the equation because I have more x's over here, and then I won't have to work with negative numbers, and I'll show you what I mean. So first step I want to do is get the x's on the same side of the equation. And I'm going to write these extra steps that you don't need. I'm going to subtract an mx from both sides of the equation minus mx minus n. All I did, and I subtracted, because here I have a positive mx, if I subtract an mx, that's going to eliminate the x's on this side of the equation. And I simply have n is equal to, I subtracted mx over here so that the equation's in balance. Like terms now. It doesn't matter that there's multiple variables. 2mx minus 1mx, 2 apples minus 1 apple, I have 1 mx left. So that's, but I'm not going to write the 1, I'm just going to say mx minus n. Okay? If this was 2x plus 3, you'd know exactly what to do, wouldn't you? You would subtract 3 from both sides of the equation. But it's mx minus n. We only want to be able to have, only want to leave those x's on the right hand side of the equation. So since we've subtracted an n, we're going to add an n to both sides of the equation, mx minus n plus n. What happens? You have 2n over here is equal to mx alone. Negative n plus n, they go away. If this was 2x, how would you solve this? You would divide both sides by 2. But it's not 2x, it's mx. So you just divide by the m, because x was multiplied by m. Then you see if you have any common factors. I don't remember that being the answer. Let me check. But it is. We have a common factor of m. And we have 2n over m is equal to x. So I think there's something a lot of time that goes on in our mind that says this can't possibly be the answer because the answer has variables in it. But with what they call literal equations, literal equations are always going to have a variable as a part of the solution. And it looks weird to us because we're used to having just, at the beginning stages of algebra, we're saying that x is equal to 17, x is equal to negative 2/3. How can it be possible that we've got an answer that still includes variables? It just is. That's how this process works. Now, of course, if we had solved with the x on the left-hand side of the equations, we would subtract a 2mx from both sides of the equation. Mx plus n is equal to 2mx minus 2mx minus n. Okay? Negative 2 plus 1 is a negative mx plus n is equal to 2mx minus 2mx, 0, minus n. Okay? We want to isolate the term that contains the variable. We're going to subtract an n from both sides of the equation. Plus n minus n is equal to negative n minus n. Negative mx is equal to, here's that issue of subtracting with negatives. You already have a minus 1n, you're going to subtract another. Negative n minus n, or negative n plus the opposite of n, it's going to be a negative 2n. Now, we don't care about all this, and we definitely don't want the negative sign, so what do we have to divide both sides of that equation by? You have to divide both sides of that equation by negative m. Then you have x is equal to, do we have any common factors here? Yeah, we've got that negative sign in the numerator and the denominator. That means that we have a factor of negative 1 in common. So those negatives cancel, and you have 2n over m, which of course is the same answer that we had here. I just like to work it this way because I intensely dislike messing with negative numbers, because negative signs, because I know they trip me up. Either approach obviously works. Okay? And then the last one that you had was where you were working with converting a repeating decimal into a fraction to show that repeating decimals are fractions. And that was back on the last section, and you had number 31. It says find the reduced fraction form. This is 4.4 2.4395, number 31, and I don't think 31 is what you wanted. Let me look and see. It was actually number 32 that you wanted. Which was 0.6381. And I'm not going to take the time to go through this because, frankly, I don't have the time right now. I have other places that I need to be. But let me point out what they had you do. And I'm wondering if this was your difficulty. Because you do have your solutions manual. And we're going to be getting into more stuff as we move on, where there's actually more work off to the left-hand side of the equation, off to the left of the student text. Make sure that you are taking full advantage of the solutions, because that will help you, because they'll be beginning to put some steps in, and you'll be able to catch some of your stuff on your own once you've tried to do the problem, gotten it wrong on the correction, you've still been puzzled. I think we're getting close to the point where this is going to be helpful to you. But the key to this little tricky way of converting a repeating decimal into a fraction in lowest form is realizing which part of the number repeats. Because what we actually have here is 0.6381. 381, 381. The 6 itself doesn't repeat. And if you look at your solution on page 32, they simply want you to be able to multiply so that your repeating parts will cancel out. And that's why they multiplied by 100. And this is sort of a non-answer to finish this video up with, but look at that again. See if the issue here was that you had the repeater bar going in the wrong direction. If it doesn't make sense to you, honestly say, go ahead and don't worry about it. I will take this to this step right here. It says x is equal to 63.81 over 99. That's just dumb. And you're going to get to this point and say, it doesn't make any sense. And then how in the world did they go from here to 6381 over 9900? They did that by remembering that when you multiply, that fact that the multiplication property of equality, that if you multiply anything by a value equal to 1, you don't change its value. What they did was they multiplied by 100 over 100. Because when you multiply 63.81 by 100, you get 6,381. 99 by 100 is 9,900. Then you divide to reduce that to lowest terms. And this whole problem right here is just an exercise in nonsense, in my opinion. If I were able to take the time to go through and look at all of the assignments that Bob Jones suggests that I do, because what I use for our homework assignments is the mid-track, it's the average assignment. I never would have assigned this one. It's a waste of your time. And you can laugh at that. So I'll see you on Friday, Abby. If you've got problems that I don't address in class, I'm more than happy for you to say, hey, make me a little video, because send me an email that says, make me a little video, show me this one and this one, because I'm happy to do that for you. Talk to you later.